Okay, good morning, students. We are continuing with our session, and we are looking at enlargement, as Mrs. Cameron said just now. So you're going to be looking at what's on screen, and you are going to be telling me what you noticed about even the word enlargement that is on screen right now. You may type it in the chat, or you can unmute, of course, after raising your hand. All right, Shanice. So it is big, it got bigger galaxies saying, all right, awesome, great. So of course, when we looked at, an overall definition of transformation in our previous video, we would have seen where we spoke about some transformations resulting in a change in size. So I'm happy that you would have seen that even the words that we have on screen were changing size. All right, so I'm going to now show you an image and, well, three images to be exact. So we would have heard, as we've been looking at transformation for some time now, so you're already familiar with the term object and with the term image. All right, so on screen we have an object that's labeled. We also have an image 1 and an image 2. All right, so beneath it, it asks you to describe the relationship between the object, which is the original, and the images. So feel free to talk, whether in the chat or on mute, and tell me what is it that you're noticing when you compare, for example, the object to image 1. What's happening here to our tiger, I think that is. All right, Acacia, go ahead.
Miss, it got increasingly larger.
All right, so remember we're looking at the object and image 1 in particular. So let's talk about that. How does image 1 compare to the object?
Oh, Miss, it's smaller, Miss.
All right, so image 1 is smaller than the object, and I see it in the chat. Someone says the object is larger than image 1, but smaller than image 2. All right, thank you for that. Awesome. So as you would have seen with the words, we're seeing a similar thing happening here in terms of the change taking place in the size. But not only that, for this diagram, we're noticing center. The word center has been highlighted in red. All right. And as we look at those line segments coming from the center, it almost looks as if we have some light rays, spreading out. And we're going to learn some more about this center and why it is important that we're able to, one, identify it. All right. Or if we're told where it is, we need to first locate it. So as we progress through the session this morning, we will hear a little bit more about that. So thank you for sharing what you noticed. Now, as we continue, when we talk about enlargement, as we said earlier, it's one of the transformations, right? But it produces an image that is the same shape as the original, but is of a different size. So previously, when we looked at rotation, we looked at translation in some previous sessions, we looked at reflection, we would have seen images that were same size, same shape. But for this one, we're noticing that the size is different. Another way of putting it is that an enlargement is a two-way stretch or shrink of the original figure. And you may be wondering, what do I mean by a two-way stretch? So we talk about a two-way stretch. We're saying that the object is being stretched both horizontally and vertically. So it's almost as if you hold it at one corner. Let's imagine with your mind's eye a rectangle, and you're holding it at one corner and you're pulling it diagonally. What's happening to it is that it's changing in width and it's also changing in height. And that's what we mean when we say a two-way stretch. All right, so it's stretching vertically and it's also stretching horizontally. And that is how it's keeping its shape. All right. Now, as we continue, how do we describe an enlargement? So many times when we go to the exam, we are given certain transformations and we're asked to describe it. So usually you're asked, first of all, to say what the transformation is. So you need to identify, is it a reflection, which was done most recently? Is it a rotation? Is it a translation, and those kinds of things? Now, if you look and notice that it's an enlargement, there are certain things that you must include in your description, all right? So we're talking about the scale factor or ratio. That's one term that you have to be familiar with. Now, what this does is that it tells you by how much a figure is enlarged or reduced. So whenever you see the scale factor, that's what it's telling you, by how much the figure is enlarged or reduced. And I'm happy that I have enlarged here and reduced, because many times we may think that enlargement only speaks to an object, getting larger. So you might be fooled by that phrase, but just so we know, it speaks to just a change in size, and so the figure can actually be reduced. All right, and as we said in the definition, we talked about shrinking as well. All right. Now, the other thing that's important is the center of enlargement. So once you're describing an enlargement, one, of course, you're going to say it is an enlargement. You're going to include the scale factor, and you're also going to include the center of the enlargement. All right. Now, as we proceed, so you're going to hear a little bit more about what these things are, how to find them, and that kind of thing. All right. So now we are going to do a little bit of exploration so we can hear a little bit more about the center and the scale factor and see what these things are and how we go about using them to help us as we discuss object and image. All right. So on screen, we have a right triangle, and we're using this strategically. And we're gonna look at some things that will be a little bit clearer to see when we have, vertical and horizontal line segments on our polygon. All right, so don't mind that. Now, the first thing I'm gonna do is to enlarge this triangle. And if you notice, there's a K value there. It's currently set at 0. So I'm gonna be enlarging this triangle using a scale factor of 2. And you're gonna look and tell me, what is it that you are noticing about this image? All right, and I'm going to be asking a few questions. So I've enlarged triangle ABC using the scale factor of 2, and my center of enlargement is labeled D at the moment. All right, so my center is identified as D. My object is triangle ABC, and my image is triangle A prime, B prime, C prime. So what's the first thing that pops out at you? What's the first thing that you notice with the image? I'm gonna pause and allow you to share. No one wants to share? Okay, Danae is saying it gets bigger. All right. I saw that too, so it did get bigger. So let us zoom in a little bit more on some specific things. All right, so let us look at the distance, for example. So we said the center is at D, and let's take, for example, the point B on the object. What's the distance from D to B? Can anybody type in the chat or unmute and tell me? What's the distance? D, B.
Mrs. Thomas?
Yeah.
Oh, I was just also saying, let's use the reference points so that they can also reinforce that scale.
Okay. All right. So Dani has typed in the chat. She said 2 units. All right. Awesome. So that would have been explored previously in terms of how to go about identifying the distances or the lengths and where to start and how to count your intervals. Awesome. So Dani is saying 2 units. Do you agree? Do you disagree? Let me know in the chat if you're agreeing with Dani or if you have another answer. All right, Abigail is saying she agrees. All right, so the distance dB is 2 units. Now, let us check the distance from D to B prime, which is the corresponding point on the image for the point B on the object. All right, so let's see D to B prime. Can anybody let me know what that distance is? Let me know in the chat.
Mr. Can you repeat?
The distance from D, the center, to B prime. All right, and I see the chat lighting up. Persons are saying 4 units. All right, so let me ask you then, what do you think, and bearing in mind the scale factor of 2, what do you think is happening to this particular distance? So we notice from the center to B, that was 2 units, and from the center to B prime is now 4 units. Can anybody tell me what they think is happening here before we explore another length? All right, Dani is always out of the blocks early. All right, Dani, I see your answer. Let me see if anybody is saying anything else before I let you know if that's what I am thinking. Come on, man, let's see. Don't let me have to search the chat, you know. I mean the participants and see who to call on, eeny, meeny, miny, mo. All right, Acacia is saying she noticed that difference. The difference is 2 units, but she's not sure, and that's fine. Not a problem if you're not sure. All right, but it's good for you to say what you're thinking so that, you know, if there are errors, we can address it. All right, Justin is saying ×2, miss. All right, I'm not gonna tell you if you are correct yet. Let's check something else. Mrs. Cameron Edwards, I'm gonna ask you to just move my object out a little bit more. Make B maybe 3 units, or all right, 4 is good. That's fine. All right, so let's see if we can tie this up. And I'm doing this specifically for one of the responses I saw about the difference being 2. So let's check what's happening here. Remember now the scale factor is still 2. Let's look at that same distance from D to B. What is that distance now? Shall we see the distance from the center to B? All right, so that's 4 units. So the distance from the center to the object, a point on the object, is 4 units. Let us now check from the center again, and now we're going to the corresponding point on the image, which is B prime. 8 units. All right, I see the answers popping in the chat already. All right, what are we seeing happening here? All right, so think about what you saw earlier, and then think about what you're seeing here, and tell me what you're noticing overall. All right, Acacia is saying message ×2. All right, anybody else? So I'm watching the chat very closely. All right, Danae is saying the same thing. All right, so I think Acacia is now cleared up. All right, awesome. So we're noticing that this distance has been multiplied by 2. Now let us check on our object. Let's just choose a side. Eeny, meeny, miny, mo. All right, let's choose AB. Pretty easy for us to see. So let's look at AB. What's the length of the side AB on my object? And I know I repeated myself when I say AB on my object, because AB is only on the object. The image is labeled with prime. Somebody said 2. Who was that? Didn't see the person who spoke. Just unmute and say it again. Jaden, that was you?
Yes, miss.
Okay, awesome. All right, so 2 units, and I see the chat lighting up with 2 units. Now let us look at A prime, B prime. What are we seeing there? And galaxies out of the blocks pretty early. 4 units, 4 units. All right, good. And I'm gonna do, before I ask you what you notice, so let's just hold that right there and let's take a look at BC. What's that length? The length BC. 1 unit, awesome, awesome. Okay, fantastic. Now let us look at B prime, C prime. All right, and I see the chat lighting up, but I still want some more persons, because I don't hear from some persons yet. They're not typing in the chat. If I don't see Christopher, is like, that is you I was gonna call, All right, so 2 units, awesome. So now that you have looked at AB and you've looked at A prime, B prime, and you've looked at BC and B prime, C prime, what do you think is happening to the lengths of the sides on the object and the image? What's happening? All right, someone says doubled with a question sign, not so sure. All right, that's fine. As long as you're sharing with us what you're thinking, we'll clear it up. Danae's saying times 2. Acacia say, yes, it's doubled. All right. Yeah, it gets doubled, Christopher. All right, awesome. So I'm noticing those same things too. All right, so I noticed that the lengths are doubled. Interesting. Again, remember the scale factor is 2. All right. Now I want to touch on a few other things. So I'm going to ask you, let's take a look at the side. Let's keep on looking at AB and A prime, B prime. So apart from the fact that the lengths have been doubled, is there anything else? Think about what you know about lines. Is there anything else that we can say about the line segment AB and the line segment A prime, B prime? So we already said the distances or the lengths have been doubled. Is there anything else that we can say about line AB and line A prime, B prime?
You're still saying that it's doubled.
Oh, that came in earlier from the previous questions. Let me give you a hint. I'm gonna just drop a letter in the chat and you're gonna tell me which word you think I'm thinking of. Starts with a P for the persons who are on YouTube and not seeing the chat here.
Miss, could you repeat the question, please?
I'm asking, what do you notice apart from the fact that the lengths have been doubled? What do you notice about line AB and line A prime, B prime? And I've dropped a hint in the chat with the letter P. All right, as is Serena and Abigail saying they are parallel. All right. Okay, and somebody asking if they are parallel. You tell me, because it's kind of easy to see parallel lines on your graph paper, especially if they are vertical or horizontal, which, as I said before, we chose this triangle because we wanted to see a couple of things a little bit clearer, you know? All right, parallel it is. That one stumped you? Oh dear. Hush, 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 hush. Lerona, I hope I get the pronunciation right. Hush, my darling. It won't stump you in the exam. You know why? Because it stump you from now. And you're on the session now, so you see these pairs, this pair of parallel lines. And might I tell you that the other, let's say, for example, AC and A prime, C prime, if you actually examine them closely, you would notice the same thing happening. They are actually parallel to each other, right? And again, the scale factor is 2, and we're noticing the lengths have been doubled, all right? Now, let's take a final look. We want to look at some angles, you know, to see what's happening with the angles, all right? So on my object, I am seeing an angle that is 26.57 degrees, okay? And I'm using that loosely, that 0.57, all right? So 26.57 degrees on my object, right at angle A. What am I seeing at angle A prime, right up there where that angle is? Is it the same? Is it different? Is it more? Is it less? Casey is saying the same, and I think somebody answered unmuted and said no when I asked, is it different? All right, good. So we're noticing that those two angles have the same measurement. Now I'm going to ask Miss Cameron to get the measurement for the angles, angle C prime in, and let us compare and see if the angle there is same or different from the measurement at angle C. Right, so someone is asking, Miss, but how is it the same? All right, so remember we're looking at the size of the angle. All right, hold on, Mrs. Edwards. All right, so can you hover back over at angle A, the angle at A for me? I want to answer this student in the chat. So hover for me at A. All right, good. So over at A, where Miss is pointing, we're seeing an angle that has a measurement of 26.57 degrees. Awesome. Hover at A prime for me. Are you seeing the same measurement there?
Yes, Miss.
All right, so that's what we're talking about. The size of the angle is the same. So now we're going to be comparing the angle down at C and the one at C prime. And we're looking to see if we're noticing anything about those two angles. How do they compare to each other? Are they the same or are they different? So we're looking at the 63.43 degree. That's over at C. And when I look over at C prime, what am I seeing there?
It's the same thing.
The same thing. Awesome. Good. So what does that tell me about these shapes? The object ABC and its image A prime, B prime, C prime. So we see the angles are the same, but we notice that the lengths were multiplied by 2 or were doubled, as some of you said. So if we have a situation like that, what can we say about the object and the image? Are they congruent? Miss would have mentioned, or you would have heard this word in previous videos, previous transformations. Can we say that these are congruent, yes or no? Remember earlier, Miss, in the previous session, Miss would have spoken about congruent, and she mentioned that the angles were the same and the lengths were the same on both the object and image. And she said, when that happens, it's congruent. Are we seeing that happening here?
Miss, no.
No. Okay. So we can say that in this case, we're not seeing congruence. What can we say about them then? Look like I need to drop another letter in the chat. So let me drop it in. There's another word that we use when the angles are the same, but the lengths have been whether multiplied by 2, 3, a half, whatever it is. The lengths are proportional. Let me use the correct term now. The lengths are proportional to each other, but the length of the angles or the size, sorry, of the angles are the same. So here's the letter in the chat. I'm looking for an S word. Does anyone know it? So it's not congruent, but it is something. And I'm not giving you cues, but you need to know these terms because you may have to use them in your exam. Scale. Someone is saying something?
Right, Mrs. Mandel. You know, like when you have sisters or brothers, they have a kind of look. What is that look? Is that what you're getting at? That that kind of look, they don't look the same, but they kind of look guys,
Okay.
that's the word we're looking for.
I know we're running out of time.
Look, I see somebody popping it there.
Yes.
Is that the word special?
Not that
no,
one.
No,
That's pulling up the chat.
In the chat, Abigail is right there and a couple of others.
Lorona just said it, miss. She said it's similar.
Look at that.
Right. Thank you so much, Mrs. Lodge Fenton.
Did you
Slay
see
you, oh dear. No. Look here. It's right here. So you must make the mistakes, so that when you go on the exam, you know the words. All right. So we're talking about similar, awesome. So the triangle has changed in size in terms of the length, in this case being magnified. But the angles are the same. And so we say they are similar, awesome. So those are some of the things that we're noticing about the enlargement. Good. The other thing I'm going to ask you to pay attention to. So we looked at the size of the angles being the same. We looked at the distance being multiplied by 2 in this particular case. So I want us to change the scale factor a little now. All right. So I'm going to ask Miss to change the scale factor to 0.5. Let's see what happens there. And then we can have a little bit more discussion. And I know we are approaching the 12 o'clock time, and we would have said this session is to end at 12. However, I'm craving from you maybe another 15, 20 minutes. Please type in the chat if you're okay with that. And then we're good to go. All right. All right, Shani is awesome. I see a response. Yes. Okay. No, some persons were saying they're hungry. Me too. So I'm looking forward to having my lunch. All right, great. So I'm going to ask Miss to remove the angle measurements. We would have explored that. And we're seeing it already being the same, but I don't want to crowd the diagram. So let's just remove those for now. You can leave all right, go ahead. We already explored them. All right, so let us talk now about what's happening with this in terms of the length. All right, so I'm just gonna grab a point, all right, a line segment rather. So let's look at, again, A prime, B prime, because those easy to see. A prime, B prime. What's the length there?
1 centimeter.
1 unit. All right. And remember now that's the image. Sorry. So let's look at the object. What's the distance on the object? So I really should have started at the object first so you can see what's happening because the object is the original. So let's talk about the length AB. 2 units. Thank you, Lorona, Bree. Awesome. So 2 units. So the object AB on the object is 2 units. But when I look at A prime, B prime, I see 1 unit. What is happening here? Can anybody tell me what's happening here? Reduced, smaller. But let us get a little bit more specific now. So I'm happy to say that it's reduced and it's smaller. But can we say by how much? By half. Somebody saying by 1, you sure? So let's look at BC. What's the measurement? Okay. What's the measurement for BC? What's the length?
0.5. The object, 1 centimeter.
BC, awesome. So BC is 1 centimeter. Lerona, we're just looking at some lengths. All right, so I've changed the scale factor to 0.5, which is the same as a half. All right, and I'm now looking at the lengths on the object, and I'm looking at the lengths on the image and seeing how they compare. All right, so we looked at AB and we saw that it's 2 units. We looked at A prime, B prime, and saw that it's 1 unit. And we're saying, oh, some people in the chat are saying, oh, it looked like it half missed because half of 2 is 1. So we're now looking at another to see if we can see what's happening with corresponding lengths on the object and image. So we're now going to be comparing length BC with its corresponding length on the image B prime, C prime. Yes, Miss Harris, that is so. So let's look at BC. What's the measurement for BC, which is the length on the object? 1 unit. Good. Let's look at B prime, C prime. What are we seeing here? 0.5, 0.5, someone not certain, some are certain. So it's actually 0.5, you are correct. So what is happening to the lengths? Are they being multiplied by 2 or are they being halved or multiplied by half? You tell me.
Multiplied by 2.
You're sure?
Are you talking about the smaller ones?
So we remember the object is the original. So we're always working from our object when we talk about the scale factor. So wait is right, Lerona, we're waiting. Let's check. So remember, we're working from our object to the image. So what's happening to the lengths? Are they being multiplied by 2 or are they being halved?
Miss Half.
Half. Good. Awesome. All right. So we're noticing here that the scale factor is really giving us some good information. Remember, we said earlier that the scale factor tells us by how much the figure is reduced or enlarged. So the scale factor is giving us some critical information here. When the scale factor was 2, we noticed all the measurements were being doubled. So when we looked at the image, the lengths on the image were always twice that of the object. But when we went down to 0.5, we noticed that the lengths were no longer being multiplied by 2. They were now being multiplied by 0.5 or half, right? Are you seeing what I'm saying? Type in the chat and let me know if you are clear on what I just said.
I'm sorry, Miss, can you repeat that, please?
So we're saying that the scale factor gives us some important information. It actually tells us by how much the length on my image has been magnified or has been multiplied. Good. So when my scale factor was 2, I noticed that when I compared the object to the image, the lengths on the image were doubled. They were 2 times. But when the scale factor was 0.5, I noticed that the lengths on the image were half of what the object was. So I'm asking if you're clear now with that.
Yes, miss.
All right, yes, miss.
Awesome. All right, so we're just gonna look at maybe 2 or 3 others. We're not gonna go into every single detail, but just for you to notice some differences that are coming out, and then we can tie it up. Lerona, I like how you think. I like how you think, because that's literally the next one I'm going to. So she's asking what would happen if the scale was 1? With the thinking emoji, I wondering too. So let's check. Miss, can you get the scale factor of 1? And let's see what's happening. It would be the same. Let us see. Hover over A for me, Miss. All right, so it means right at that point, we have A with coordinate 4, 4, and we also have A prime with coordinate 4, 4. And Lerona said, thought so good. So here we have the object and the image, well, the image actually lying right on top of the object. So, can we use that C word in this case? That word congruent, do you think? I wonder. Let me know what you think in the chat. All right, somebody say yes. I don't know. I need to hear from some other people if we can really use that C word. Acacia is saying yes. I'm not convinced. Abigail saying yes. All right, so I see some other people. The angles and the lengths are the same in this case. Beautiful. So we can apply that C word for this one. Could we apply it for scale factor of 2? What about half? What did we say? No, miss. All right, awesome. Now, so far, based on what we've looked at and where our center is, we saw where the object and the image, they all appear to the right of where I have this center. Wait, what was the C word? They're not going to beat it, and I'm going to type it in the chat for you. All right, so Shanice is ahead of me. Beautiful. All right, so we would have looked at 2, 0.5, 1 as scale factors. And we're seeing all of those things, you know, appearing on one side of the center of enlargement D. But I want us to also take a note of something. Let's look at the triangle again. Put back scale factor 2 for me, miss. What about the orientation? How is the shape turned? Them look like them turn the same way. And I'm using the pattern now. How it look? How does it look? In terms of its orientation or how it is turned. So let's face in the same direction. All right, Acacia. Yeah, look, they're the same in orientation. All right, so when we look at the object, it's sitting on line segment BC, and I look at the image, it's sitting on line segment B prime, C prime. And I look at A, right up there at the apex up there, and I'm seeing A prime in a similar position. So we're seeing that the orientation is the same. Now, I did ask for a certain number of minutes, and I do not want to exceed that. So let us just look quickly at what happens. Anybody thought, Lerona, you were always thinking ahead. You think about any negative scale factor yet? Something to think about. Is it possible for I wonder if it's it you were typing, for the orientation to change? Let's check. So let's try a negative scale factor and see. And I like the fact that you're exploring and you're asking questions that, I wonder if it would be inverted. I don't know in a galaxy. Let us see. So Miss has changed the scale factor to, oh, it's because we have moved away. So you can pull it back a little closer so it stays on screen, Miss. The object a little closer to the center so we can get everything a little bit tighter. All right, so Someone said it would be inverted. Let us check. So we're looking at scale factor of -2. It would look like a reflection. You're sure? Interesting times. So let's look at it and see what's happening. First of all, I want to ask you about the lens. So look at the lens and tell me what's happening with the lens on the image. Corresponding lens, of course. So if you're looking at AB on the object, you must be looking at A prime, B prime on the image. We have to compare corresponding sides. Flip like a flipogram. Okay, as if it were flipped, it wouldn't map together. All right, so we're looking at the fact that it's inverted, but remember, enlargement, especially certain scale factors. We saw, for example, that only one scale factor of 1 gave us congruence, but the others we explored so far gave us something similar. So we have to bear that in mind as well. So let's look at the distances. Can anybody tell me what's happening? What's happening with the distances? So let's look at AB and A prime, B prime. What happened?
It increased by
Increase.
1.
It increased, but you have to tell me how, what happened to them? What happened to the length of AB to give me A prime, B prime?
It gone up by 2. It doubled.
As in I added on 2. So let's get our things clear. I want to know.
Yeah, added on 1.
Pardon?
I think you added on 1.
You sure? What's the length of AB?
2.
And what's the length of A prime, B prime?
4.
And somebody is still saying that we added on how much? Somebody saying we added on 2. So let's see if it's we add 2 all the time. So let's look at BC, because I want to get it clear.
BC
So B,
1.
and what is B prime, C prime?
2.
So I never add on 2. In this
But the
case,
shape doubled.
whatever you tell me has to apply.
Miss,
Who is saying miss?
it was doubled.
So you identify yourself first and then you tell me.
Acacia.
Oh, Acacia, you're saying no?
Miss, it's been doubled.
It's been doubled. And Lerona, I did see your thing in the chat. And Shanice, all sides of the shape has been doubled. The length of the sides have been doubled. All right, so we're seeing something similar to what happened when we had the scale factor of 2. Somebody is saying something? If not, then remember to mute after you've spoken. All right, so we have looked at it. We have looked at scale factor of 2 and we saw the length doubled. We're looking now at the scale factor of -2. We're seeing the length doubled. My question is there something different with this than what we saw earlier? And if yes, what's the difference? So I see it's negative. I think you're referring to the scale factor now, but I want to know about the image itself. Danae is saying it's flipped. I don't like that flipped word. I know what you're trying to say, but I wouldn't want to use that flip word. All right. All right. So somebody's saying it's inverted. I prefer that because a lot of times when we speak about flip, we associate that with reflection 1 and 2. Remember as well that this one speaks to a size change. And so, you know, we have to focus on those things. So Ms. Harris is asking in the chat for all of you to answer. What do you notice about the location of the image in the two cases? Awesome question. That's actually the next thing. What do you notice about the location as it relates to the center of enlargement? So previously we saw the object and image on the same side of the center. What are we seeing here? Different quadrant, opposite sides. All right, I'll take those. I'll take those. All right, so we would have looked at +2, +1/2, +1, and we saw all of those lying on the same side. And the minute we dropped a negative, we saw two things happening. One, we saw the shape being inverted, so the orientation not the same anymore. And we saw that they're on opposite sides of the center of enlargement. Awesome stuff. Fantastic stuff. All right. So you're gonna just tell me in the chat, what do you think would happen before Miss does it if we had a scale factor of -0.5? Let me know in the chat what you think would happen if we had a scale factor of -0.5. Nobody wants to take a guess? I don't see the chat lighting up. What do you think would happen? Lerona said it would have still been halved, meaning the length, but still inverted. Who is saying it would look the same, but smaller? Let me see who that person is. Can't see the name. Bree, that was you? Okay, what do you mean? They would look the same. They meaning what? The object and image would look the same? What do you mean? You have to explain a little bit more as we wrap this exploration part. You may want to unmute and tell me, because it might be a little difficult to type that in the chat.
May I go ahead and share it then?
Pardon?
Go ahead and share the -0.5.
Yeah, go ahead. Is that what you were saying, trying to say, Bree? Let me know. Yeah, all right, good. So we're noticing a few things. Please go back to the PowerPoint, miss. So we're wrapping this up in 3 minutes. When we come back in the afternoon, we're gonna look at a few other things on enlargement in terms of what to do if you are given the enlargement and you're asked to find certain things. Also, how do you actually go about performing an enlargement? So we'll take that up in the afternoon session. All right, but for now, I just wanna combine what we just explored, and you can take some screenshots of what are the things that we noticed as we explored GeoGebra. So the properties of the enlargement that we would have seen is that the length of each side of the object and the image, they remain in the same proportion to each other. What that means, what are we saying here? If the lengths have been doubled, for example, for a scale factor of 2, then all the lengths have been doubled, all right, on the image. Good, so they remain in proportion, in the same proportion to each other, all right? So if you check a pair of corresponding sides and you notice that, you know, it's doubled, if you check any other pair, you will notice the same doubling happening, or whatever the scale factor is. It could be tripled. The scale factor is 3, all right? Then we also noticed from our exploration just now that each line on the image is parallel to the corresponding line on the object. All right, so we'd have checked that with one particular example where we looked at a pair of corresponding sides. They were actually vertical, so it was pretty easy to see that they were actually parallel to each other. All right, we also noticed that all the angles remained the same, and we looked at that, right? So even though the lengths were proportional to each other, so sometimes they were doubled, tripled, halved, whatever it was, but when we looked at the angles, they remained the same. And so we said object and image are similar. All right. So basically, the scale factor tells us, so when you look at it, it tells us the image may be smaller, which we saw with the half case. The image may be larger, which we saw with the case of scale factor 2, maybe the same size, which we saw with scale factor 1. But we also saw that the orientation may be changed. In other words, it may be inverted if the scale factor is negative. So those were some of the things we saw coming out. And we said congruence only happens if the scale factor is 1 or -1, even though we didn't actually explore -1 today. All right. So as we close this particular session and we resume at 1, I just want to remind you of what happens with a positive scale factor versus a negative scale factor. Move to the next slide, Miss. So our positive scale factor, just a gentle reminder, the object and its image will lie on the same side of the center of enlargement. And I'm actually going to review this as we come back for the afternoon session. All right. So object and image are on the same side of the center and the orientations are the same. However, as we saw with the exploration, whenever we got a negative scale factor, we were seeing some things happening. Yeah. We saw that the object was on one side and the images were appearing on the other side of the center of enlargement. And we also noticed that the images were being inverted. All right, we'll pick this up in our afternoon session. Acacia, awesome. Feeling very confident about this topic right now. Thumbs up, darling. So make sure that you come back to the afternoon session and we'll pick this up. We'll look at some examples, etc. All right, so we'll pick up for part 2 of enlargement and take us into